Okay, so now let's see. We have to figure out what to do with the map getting into 0 to 1, and it's you had some time to think about it because our memory card on our camera got full, so I went up and downloaded the videos to free up some memory, and so you had about 10 minutes. So what idea did you come up with?
Well, I've realized that each of these, like 1/2, 1/3, 2/3, the combination with the numerator and denominator is going to be unique to that rational number. So there's not going to be two fractions with a half. So we just need sort of a way to represent that, and you can sort of do that on the coordinate plane. Like, think of the numerator as going in the x direction and the denominator is going in the y.
Okay, this is I'll keep this set of numbers there. Alright, so the numerator goes in the x, and the denominator goes up there. Okay. Right.
So, you'd start with 0, 0, which
we
fine.
It's fine. Yeah,
And so
have
we
that one in there or not.
start here. This would be 1, 1. So this would be 1, and then you'd have a half up here. 1, 2. And so with these numbers, you can go up 1/3, 2/3, 1/4, 2/4, 3/4, and sort of create a pattern like this, and you sort of get this, excluding 1, you get this right triangle shape.
Okay.
And then you have to get all of the points on this, but you can't really go just in this direction because you'd never be able to turn and come back and get these, so you have to sort of like snake along.
Okay, show me how you
Like,
snake along.
if you first get this, and then you move up to the next row and you get it, and you move up to the next row and you hit all of those points, and sort of snaking along like this. And that sort of collects all of the rational numbers less than 1.
Yeah. That not only is that a good way to do it, that is actually exactly how Cantor did it. Using this snaking idea. And then with your idea, once we get these, then we can just do a separate map that maps each one of these to two things, which is what we did before. Cantor's argument, I think, was, although it used the same idea, it actually accomplished both steps at once. Make sure I'm on screen. So I'll just put the grid points in.
Yep.
So we'll represent the rational numbers as a ratio, just like happened here. And Cantor said, well, you just start at this one, which is 1, 1, and then you just do the snake this way,
Yep.
etc. But your snaking algorithm is also really, really good. So it's exactly the same idea, right? Yours is actually really even like 1/2 step more clever, because you just say, let's solve it on 0 to 1, and we can solve it everywhere. Cantor just solves it everywhere all at once. But yeah, that's really neat. And so if you wanted to, in your algorithm, if you wanted to talk about the 100th rational number, the order is a little bit strange, but you just walk down the path 100 steps, and wherever you land, you land. And if you needed to figure out a formula for that, you could. It would be a complicated formula.
I suppose you could make it less complicated by maybe starting at the beginning of each, like you go from here, finish that, and go back to the beginning every time.
Yep, for sure. For sure, because then it's just 1 plus 2 plus 3 plus 4 plus 5.
Yeah.
So you actually would know a formula for the beginning of each row. And you would then say, okay, what I'm looking for the 100th number, the nearest one I know is, it's probably